So today we're going to get more into talking about what is the sine inverse function, cosine inverse, tangent inverse. And some important inverse information to remember is one, that for a function to have an inverse function, the original function must be 1-to-1. And remember that means it has to pass the horizontal line test. Second important thing is that if you need to get the points for your inverse function, simply switch the ordered pairs of your original function. And then third, the domain of your original function equals the range of your inverse function, and the range of your original function equals the domain of your inverse function, the whole you switch x and y thing. All right, so keeping those three things in mind, let's start by graphing sine of theta from negative pi to 2 pi. Okay, because we know that sine could keep going forever, but we're going to restrict it from negative pi to 2 pi. So, draw our graph. And out here I want to go to 2 pi, cut that in half, that gives you pi, cut that in half again, you get pi over 2, and halfway between these two is 3 pi over 2. Alright, and then coming this way, negative pi over 2, negative pi. And sine exists between -1 and +1. Okay? So at the origin, which is always where you want to start whenever you're dealing with a trig function and graphing it, sine starts at 0, 0. From there, it goes up, down, down, up. And following the same pattern that going to the left, we know from here it'll go down, and then it'll go back up. So here's our nice, beautiful sine curve. Let's go ahead and label these ordered pairs. So this one is negative pi, 0, negative pi over 2, negative 1, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. All right, so those are our ordered pairs there. If we look at the domain for this function, the way we have it right now is that it goes from negative pi to 2 pi. Okay. Now, we know that it would actually keep going. We're simply restricting the domain to that. The range for this is -1 to +1. And that's not restricted, that's just what it is. It only exists between -1 and 1. Now, if you look at this right now, is this a 1-to-1 function? Well, if you imagine your horizontal line just being your x-axis, you can see that it's not 1-to-1 because it does not pass the horizontal line test. What that means is that instead of the entire function having an inverse, only one chunk of it will have an inverse. So let's kind of take a moment and sketch what we think sine inverse would look like, and then we'll delve into, okay, what are the restrictions on sine inverse? So we said that in order to find the ordered pairs for an inverse trig function, you switch the ordered pairs of your original function. So the original function had an ordered pair at negative pi, 0. So on my inverse function, it's going to look like 0, negative pi. This one's going to look like -1, negative pi over 2. Still 0, 0. 1, pi over 2. 0, pi. -1, 3 pi over 2. And then 0, 2 pi. So when we look at it this way, or for our chart for sine inverse of theta, we'll see that our x values or our theta values only exist from -1 to +1. So my horizontal axis is going to be fairly short in this case. It's the y-axis, or f of theta axis, that's going to be a little bit bigger. So I need to go from -1 to +1 on my horizontal axis, and then I need to go negative pi negative pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi. Then when we plot our points, 0, negative pi, negative 1, negative pi over 2, 0, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, and 0, 2 pi. Okay. Now, when we connect these dots, I'm just going to do it kind of like dashed here for a moment, and I'll explain why. Okay. Is this a function? Well, no, because it doesn't pass the vertical line test. So we're only going to take a certain chunk of this, and the chunk that we're going to take is from negative pi over 2 to positive pi over 2. Okay, and that's the part that you can go ahead and trace it over, make it really solid. Okay. So it's just this little blip right here that is the graph of sine inverse of theta. Okay, because if we only look at this chunk of it, it is a function. It will pass the vertical line test. So if we talk about the domain for our inverse function here, it'll go from negative 1 to positive 1. Notice that's the same thing as the range, as the original. If we talk about the range of our inverse function here, well, it goes down to negative pi over 2, and it goes up to pi over 2. Okay. If you come up here and look at your original sine function, if we focused on negative pi over 2 to positive pi over 2, okay, so this chunk of the graph right here, and we just focused on this piece of it, would that piece right there be a one-to-one function? Yes, because it passes the horizontal line test. Okay? So we'll actually say that our domain is negative pi over 2 to pi over 2 for sine of theta, just to show that it's the same as the range for the inverse function. Okay? So that's the graph for sine inverse of theta.